Yes. Hey everybody, welcome back to HPC Tech Shorts, where every week we take you to the water cooler here in HPC Engineering, talk to the engineers and the other geeks that are making the cloud a great place to do your HPC. This week we're joined by, again, by Austin Cherian in Singapore. Hey,
Hello.
Austin.
Hey, Brendan.
Austin's one of our most senior developer relations engineers and is a performance junkie and on the team. And so we wanted to get together to talk about EFA. Lots of folks use EFA for their codes. Often we get calls from people on the, in our support or gets tickets from people who are having kind of not the best experience with EFA. Or at least not having the best experience with their codes. And let me just got an example here that I'll put up. Where is it? They get this kind of thing, right? They're getting stuff that looks more like the red line. Code just stops scaling after a certain number of instances, and so they're getting kind of no advantage out of piling a bunch of extra compute on. So they're not having a good experience. So I thought what we'd do is get Austin in. We'd talk about what is a good EFA, what's a good cluster setup to make sure that you're using EFA correctly and you haven't accidentally stuck some packets out over a TCP connection instead of using EFA.
Yep.
It's going to be a big thing. And then how to tell if it's happening to you, how to debug those scenarios, and how it all hangs together. So does that sound like a good agenda?
Yep.
Cool.
Sure. Yeah, I think we can take a ride through how to fix EFA if we have problems, basically.
Yeah. All right. So let's see. Let's get. Let me just put my desktop up because I've got a few things here that we should check off the list, right? So obviously that's what it looks like if things are not working for you on a particular day. They're going to look kind of like that. Just very, if you want to, by the way, if you want to get a bit of a deeper dive into EFA, go and have a look at this talk that we did. It's a couple of weeks ago on the channel. It's a talk that I did with Brian Barrett, who's our principal engineer for Elastic Fabric Adapter. And you'll get a good sort of set of underpinnings about how EFA works. But there's an offload section, right?
Yeah. So the essentially the way EFA is basically working is you have libfabric, which is the software bit of EFA, and then you have the EFA device itself. And we're basically doing an OS bypass to get to the device directly. Although to make things, if everything has to work right, you have to have both these pieces working together. The device must be enabled, and the libfabric is something that you'll be using with the MPI implementation. And that's where things can go wrong. And today we're going to actually debug through that, essentially. Right.
But so the most important piece is obviously having an instance with EFA on it, right? Having the hardware there, kind of vital. So we'll show you about that in a minute. Obviously, making sure you got libfabric installed and the kernel drivers, and having an MPI or nickel, by the way, if you're a machine learning person. Not everything in the world is MPI. It should be, but it isn't. But having the right MPI, having libfabric, and having the device there, those are kind of the three pivotal things. So how do you look? First things first, how do you know if you've got an instance that's got EFA enabled on it? If you go to this web page, and I'll flash this up on the screen in a minute. This is the EFA landing page, but if you just search in your favorite search engine for AWS EFA, you'll almost certainly find this is the first hit. Go to getting started, and you'll start seeing a lot of the documentation. And of course, that documentation will lead you to this, which is the supported instance types. Not every instance in EC2 has EFA.
That's right. So not all instances have EFA. Look for the N. Mostly those are the ones that have EFA, but there are instances that might not have the N. Like, for example, the P4D instance has EFA on it, but doesn't have the N. And that's what you want to do use for machine learning, for example. Yeah.
So if you've got an instance type that's on this list, you're on the way to getting EFA working. So that gets the hardware, sort of the checkbox for the hardware, as it were, out of the way.
Yep.
And then really the next couple of things, I guess, is where we go from there. There's three MPIs that are known to work very happily with EFA at the moment: MVAP, OpenMPI, and Intel MPI. And that's all because they're libfabric friendly, right?
That's right. Yeah. So two of those are something that we actually package in with Parallel Cluster. Essentially, the Intel OpenMPI and the Intel MPI. The Intel MPI actually has support for libfabric. Out of the box, so you can actually take an Intel MPI, latest Intel MPI, and actually have libfabric already supported with it, basically. Yeah,
that makes sense.
MVAPitch, though, you have to actually compile MVAPitch with libfabric, and that's something that you can do as well. Yeah.
Yeah, that's true. Now there's a bunch of ways to make sure that you get a good, happy environment. The easiest way possible is just use Parallel Cluster.
That's right.
We've gone to all of this pain and suffering to make sure the Parallel Cluster's got all this stuff built into it, and it just nails it first out. But there is, you could also go and, that may not suit your needs, and you may actually be wanting to go and build your own, right? So where do we want to jump off? You're going to show us some stuff, right?
Sure, yeah. So if I can just get to my desktop over here real quick. So I've got a terminal open, which basically has Parallel Cluster installed. And as I mentioned, when you install Parallel Cluster, you have two MPI versions that come with Parallel Cluster, and they're actually part of the module environment. So if you give module AV, you actually get, sorry, you have to actually log into a Parallel Cluster for that. So, so that's module AV, and it should basically show you the modules that are there. And as you can see, we have OpenMPI and Intel MPI there. And if you want to load any of these, then it's just a module load, and then you give Intel MPI. By default, you have OpenMPI already loaded. So for example, if you give which MPI run, it should give you OpenMPI over there, right? Now, let's say that you want to actually from source, build your MPI, for example, MVAPitch, for example, right? You actually have to go to where pointed to or linked to a libfabric. And where is libfabric, installed? Go to cd/opt, Amazon, and then you have EFA and lib64, right? As you can see, you have libfabric over there. So that's where you link to if you want to actually build an MPI with libfabric, right? So that's the right environment that you can get to quickly. Now, if you want to actually build or basically install EFA on an EC2 instance without Parallel Cluster, you can do that as well. And there's a link that we can put in the video that shows you to go to that link and follow a step-by-step guide of how to actually enable an EC2 instance with EFA, basically.
Right, and in fact, I'm getting that up right now. I'm just going to, here it is here. That's what it looks like there. So, and there's quite a laundry list. So this is really methodical. This is going to take you through all of the, getting EFA, getting all the EFA stack installed and an MPI.
That's
and
right.
Step you through like an OpenMPI or an Intel MPI options.
Right.
So it's pretty meticulous. So if you are going to go and build your own cluster stack from whole cloth, from blank page, just be really careful that you follow all of this stuff. Make sure that you've got obviously an EFA enabled device. And there's also some, I think I had a screenshot of this earlier. There's a little bit of fine print that you want to. EFA traffic isn't routable, and you wouldn't want it to be routable either, because that would actually that'd sucker you down a hole where your traffic is passing between whole chunks of compute instances through a router. That's just going to add massive delays and bottlenecks to the whole thing. So it's not routable, and also you can only have one at the moment. You can only have one EFA device attached per instance.
That's right.
And in fact, right now, the way that EFA is built, it's only on the largest instance sizes of each of the families. So if you're using a C5N, it's the C5N 18x large, the actual maximum sized instance type, or the 24x large, because there's a couple there. It's not the 9XL or the 2XL. Those just don't have they don't have EFA enabled. So
correct. Exactly.
Truly, we've probably just saved somebody a whole lot of debugging just with that. That one.
And if you scroll down a little bit, Brendan, onto that picture over there, that's how you enable EFA when you're using parallel cluster, right? So this is a parallel cluster configuration file. It's a snippet of that, and that's all you need to actually do to enable EFA. So even if you're on a device and you've used parallel cluster to get to a cluster configuration, without this setting, EFA is still disabled. Which means that you could be running on an EC2 instance with EFA, but it's still disabled. And this is what's required to actually enable EFA. So all of the steps that you saw that Brendan showed up to actually set up EFA, this little parameter over here just enables all of that in a short.
So like we said at the beginning, if you're using parallel cluster, it's like really hard to not enable EFA. It's really hard to get this wrong because the software stack's all built in for you. But just make sure you get all of these steps done. Make sure that you've got that N, that N instance. There's the N instance down there, right?
Right.
So this is essentially saying here's a queue for C5N18XLs. We're gonna. It's the resources are actually going to be down in this section. Here it is. There's the N, and there's enable EFA is true. And as long as you have those things, you're good to go.
Exactly.
All right. So let's get back to some real consoles. You're going to show us what happens. How do we start to figure out? How do we tell if stuff is not
okay? So now So let's say now that you've you have selected the right instance, and you probably are sure that you have the right MPI binaries which have linked with libfabric and so on and so forth, but you're still seeing performance issues. Now let's see how you debug this, right? So just to ensure that you have that EFA enabled on that instance, what you need to run is a command called fi_info and EFA, right? If you run this on an instance that does not have EFA enabled, such as this one, which happens to be the head node of my parallel cluster, you just get this error. You just get a output -61, which says EFA is actually not available from a provider. But let me switch to a compute node of that cluster, which has EFA on it and is enabled. So if I run fi-info-EFA, I should get this output, which actually shows me that the provider over here is actually EFA, right? And that's how you know that EFA is enabled.
Yeah, and you've actually just highlighted something else as well, right there, which is a head node on a cluster doesn't necessarily need to have EFA enabled, right?
Absolutely.
It's actually not essential for the head node to do that. It's going to put the jobs on the compute nodes. The compute nodes themselves need to talk to each other over EFA, and that's a big difference. So it gives you a bit of architectural freedom when you're designing your cluster. You can have EFA on the head node, go for it.
Yeah,
but it's not essential. Yeah. Okay.
Yep.
Cool.
Absolutely. Yeah. So this is something that's pretty cool. Where you can actually have a very small head node, not expensive. In terms of running that head node continuously, it could be a small T2 micro as well, right? But you can actually have a scheduler launch things on an EFA-based compute node, a set of compute nodes which has EFA on it, basically.
And let that be there's a cool lesson in that, folks, which is you could have a super cheap head node on a cluster like a T3. Scheduling jobs on compute nodes is not exactly massively complex task. So T3 is really good for it.
Right.
And a T3 could be sitting there like a pilot light on a cluster. You could just have that thing running. It's pretty cheap to just have that thing running all the time, sitting there waiting for jobs, and then it spins up compute nodes when it needs to.
Exactly.
Hey, so so we know what it looks like when EFA is there and when it isn't there. One of the things that always concerns me is what happens if somebody trips over something in their MPI scripts, in their batch scripts, or their MPI run syntax, and screws up somehow and accidentally manages to pick a TCP path instead. So how do we find out? How do we actually find out if the path that's being used is EFA?
Yep, sure. So I just changed back to my head node again on the console. And what I'm going to show you is, let's say, as you just mentioned, Brendan, I've probably used the wrong, MPI run binary, which doesn't have libfabric, linked to it, or there's something else wrong with the environment for whatever reason, right? And so I need to figure out if my binary is actually using EFA or not, right? That's basically where I arrive at in terms of figuring out whether it's I have a problem with not using EFA, even though EFA is enabled. So this is how you could do that, right? So essentially, what I've done is that I've written a small MPI Hello World program. So let me just go back to right. And this Hello World program's output looks something like this, right? So just giving you an idea of what this just prints Hello World across multiple tasks, just to give you an idea of that. But now what you can do is that you can actually have an export for OpenMPI.
Yeah, it's just like an environment variable we set.
Exactly. And this environment basically puts into debug mode, right? And it actually, now throws out all the messages that you can have when the application actually runs using a provider and EFA as the provider, for example. So let's export that. And now let's actually run the application. Let's rerun that MPI Hello World application, and we can actually go through the output. So I'm just going to submit a batch job, which is actually going to run that. And just monitor it for a second. I've already got those nodes reserved, so I'm not going to, reserve a node or spend time doing that. And now we can see that job is run. Let's cat it to see what's in the job. I mean the job output, and let's pipe it to rep for EFA. And as you can see, your output should look something like this. Your output of that Hello World program now shows you that there's a provider being used and it's EFA. And this is how you can actually make out for sure that you're actually using EFA to run this job now, essentially.
Yeah, that's actually really cool, because then now you know that the actual pathway that your packets are traveling over is EFA.
Exactly.
Okay, so that's cool if I'm using OpenMPI. What if I'm using Intel MPI? Because I'm on an Intel platform.
The way we do it is to add the environment variable in the job submission script, unlike what we did for OpenMPI, which was added as part of the.
By the way, for everybody at home and for Intel, if you're listening, this is a really, really weird way of getting this environment variable in here, and this took us quite a while to debug yesterday.
Right. Normally, SBatch is supposed to actually just take all our environment variables and then run it in the new environment, like the compute nodes. But for Intel MPI, you need to be making it part of the job submission script itself. Yeah. So I'm just going to open the job submission script for showing you what it looks like. And as you can see over here, there is this -genv I MPI debug equal to 4, which is the the debug level, right? Yeah. And now
4 is pretty verbose, right? Probably exactly. 1 would be enough, but yeah.
I'm just going to quickly exit and come back because I want to make sure that I'm using the Intel MPI now. So again, as I mentioned, to instantiate the Intel MPI as part of the environment, I can use module AV, right? So module load Intel MPI, and that should have given me Intel MPI. So which MPI run? And as you can see, it's Intel MPI. So we've got Intel MPI now. And what we're going to do is we're going to actually run the Intel version of that script, right? So and we should be seeing it running, as you can see over here.
Yep.
And it's done. And we can now.
No, you're going to have to take the E off cat, but.
Oh. That, and as you can see, you have EFA as part of the provider over there, which means that we are 100% using EFA for that run, basically. So that's how you can check with OpenMPI and Intel MPI. We just check that our application is actually running with EFA and is using EFA, basically.
Wow. Okay, so that's really cool. So that definitely covers the case where OpenMPI, Intel MPI. You could also, there is a third way to sanity check all of this stuff, right? Which is a little bit of a heavy-handed way of doing it, which is looking at the traffic.
Oh yeah. So essentially, if you want to look at traffic, you could do that for any of the network devices that are on that you use with EC2 instances, including the Ethernet-based traffic as well from an ENI device. And the same goes for EFA as well. So you can actually monitor the traffic between two EFA devices. And the way you do this is by enabling what we call as VPC flow logs. There's going to be a link in the video that shows you how to do that. But essentially what it is you enable VPC flow logs for a VPC and for a and actually you can actually tag two devices and actually see the traffic between those devices. The output actually is put into S3, where you can actually look at a output file, the traffic, and then basically grep through that to see the traffic between like two device addresses, and actually see that there's actually messages and bytes being passed between these two devices. Basically, it's a bit of a heavy lift, but that's something that can show you that what the amount of traffic is between those two devices, and you can kind of incrementally build a system if you'd like to see if there's more traffic or less traffic when you run certain types of workloads, for example. Yeah,
it's a pretty. Anyway, we might even do a blog post on that, or a tech short about it at some point in the future, just to drill into that. Okay, so this is really good, actually. Thanks, Austin, because now what we've got is we know how to make sure that we know what the right way to do things is. We know how to work out how to detect when things are going wrong, and of course. Best way to detect when things are going wrong, I mean, really is going to be when your code's performing terribly. That's going to be a pretty big indicator that you may have something weird and wrong set up in your environment. You're not getting great performance. Hopefully you're the blue person, not the red person on this graph, right? Let's see. What else is left to say? The easiest way to get all this stuff working is just use parallel cluster. Couple of commands and I mean everything just works, right?
That's right.
That's a much simpler way to do things. We're going to put a whole ton of links into the show notes for today. But actually, one of the best places to go to find all of this stuff, the best jumping off point, is to go to the EFA landing page on the AWS site, where you will find loads of sort of documentation. Tutorials, you might even find some links to some exciting tech shorts that are discussing it. And I guess we'll probably leave it there for today. Does that make sense? In the meantime, if you have any ideas about future tech shorts that you'd like to see us do, topics you'd like to see us cover, please find us on Twitter and DM us. We're totally open to ideas. In the meantime, I hope everybody has a good weekend. And hey, thanks, Austin.
Thanks, Brendan. Thank you. Thanks for having me.
Bye.
Bye.